Warm welcome and greetings to everyone. Today we are going to see about the numerical problem on thin cylindrical shell, which is subjected to the internal fluid pressure of 5 Newton per square millimeter, and the thickness is unknown that you have to design it, and of diameter 100 mm. So if the pressure inside the cylindrical shell is 5 Newton per square millimeter and mu is equal to 0.25, and the Young's modulus of the material of the cylindrical shell is 2 into 10 power 5 Newton per square millimeter. There you know that the hoop stress is the maximum stress compared to the longitudinal stress, that is equal to PD by 2T. Here thickness is unknown, so I am putting the pressure is 5 into the diameter is 100, so divided by 2 into thickness. So now the F1 is equal to the allowable stress in the material of the cylindrical shell should not exceed 100 Newton per square millimeter. Now what about the thickness? So the maximum worst stress is the hoop stress, that is equal to PD by PD by 2F, where F is the allowable stress in the material of the cylindrical shell. So that is given as 100 Newton per square millimeter. So now thickness should be greater than or equal to, pressure is 5 Newton per square millimeter, so 5 into diameter is 100, so 500 divided by 2 into 100. So what will happen? So it is 500 divided by 2 into 100, so it is nothing but 2.5 mm. So the thickness of the cylindrical shell should not be less than 2.5 mm. That means the thickness should be greater than or equal to 2.5 mm. So I am taking a thickness of 5 mm practically, because the thickness available will be 2 mm or 5 mm. So the thickness of the cylindrical shell is 5 mm. Now what will be the hoop stress and longitudinal stress in the case of this cylindrical shell? So therefore F1 is equal to hoop stress, that is equal to PD by 2T. So the pressure is 5 into diameter is 100 divided by 2 into 5. So what will happen? We are getting the hoop stress of 100 Newton per square millimeter or 100 MPa, and the longitudinal stress is equal to PD by 40, that is half of F1. So that is half of the hoop stress. So here F1 is equal to 100 Newton per square millimeter, half of that is F2 is equal to the longitudinal stress, that is equal to 100 by 2, that is equal to 50 Newton per square millimeter. Now the major principal stress in the case of thin cylindrical shell is F1, so that is equal to 100 Newton per square millimeter, and the minimum principal stress F2 is equal to sigma 2 is equal to 50 Newton per square millimeter. Now what about the maximum shear stress developed in the thin cylindrical shell? So the maximum shear stress is tau max is equal to Q max, that is equal to sigma 1 minus sigma 2 by 2, that is the average of the difference of the major and minor principal stress. So here the major principal stress is the hoop stress and the minor principal stress is the longitudinal stress. So therefore tau max or Q max is equal to 100 minus 50 by 2. We are getting 50 by 2, that is equal to 25 Newton per square millimeter or 25 megapascal. So this is about the designing the thin cylindrical shell with the fluid pressure given and the corresponding the material behavior is given. So you can able to find the thickness, and also you can able to find the diameter also provided if the thickness is given. So in the next video we can see about how we are designing the diameter of the thin cylindrical shell with the given pressure and also the allowable stress in the material and the thickness of the material. So thank you very much for patient listening. வாழ்க வையகம் வாழ்க வளமுடன். God bless.